Welcome to the Real Python Podcast. This is episode 88. There seem to be three kinds of Python developers: those unaware of type hints or have no opinion, ones that embrace them, and others that have an allergic reaction at the mention of them. Python is famously a dynamically typed language, but there are advantages to adding type hints to your code. This week on the show, we have Luciano Ramalho to discuss his recent talk titled Type Hints, Protocols, and Good Sense. Luciano was not a fan of type hints. He's only recently come around to their potential with the introduction of protocols in PEP 544. Python has adapted a gradual type system that is optional at all levels. We discuss the advantages, pitfalls, and recent developments around type hinting in Python. We also talk about the second edition of Luciano's book, Fluent Python. He researched type hints in depth for the book, which led to his recent conference talks on the subject. He also shares his experience with adding opinionated asides to the book in a fun and unique way. Cloudsmith is a secure software supply chain management tool for your Python packages and dependencies. Try Cloudsmith for free at cloudsmith.com/sign up. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Well, I want to welcome you to the show, Luciano.
Thank you, Chris.
We passed each other multiple times at PyCon 2021, sort of virtually in the Hangout sections, in the sort of post-talk conversations. One of them was Lucas's FM synth talk, and then the other one was
cool. Yeah.
Nina's Circuit Python talk. And so I was wondering, are you interested in those kind of different uses of Python, like audio or physical computing and so forth?
Sure. Yeah, I'm always very interested in that kind of stuff. I'm actually one of the co-founders of the first hackerspace in Brazil.
Oh, cool.
Called Garoa Hacker Club. And so we used to do, before the pandemic, lots of experiments of those kinds of things over there. But yeah, and there's a processing.py, which I've delivered courses, introductory courses using. I have a really good friend, Alexandre Vilares, who is a specialist in that. That's also something that anybody who's interested in Python and art should check out, processing.py.
Yeah, that looks cool. You were mentioning it just before we got started, and I brought it up here, and I'm looking through a handful of the tutorials that look really kind of fun.
Yeah.
I don't know. Those are the things that get me peaked, as far as this is something I want to experiment with. So that's cool.
And one of the things that I always found interesting about Python is really the huge range of applications that people do with it. The only major missing piece is really mobile, right? We don't really have a very good. There's the Beware collective of projects, but it's kind of experimental, at least it was last time I looked. And so we don't have a good solution for that. But for everything else, it's amazing the variety of scenarios where Python is used.
Yeah, I'm excited to try out some of these new things too. I know that, Brett Cannon's working pretty hard on trying to figure out WebAssembly, WASM, as people like to pronounce it.
Oh, that's cool. Yeah. Mm-hmm.
And the idea of figuring out the core of Python and how could we implement it in its pure elemental thing. It kind of brought me to this conversation I had with, the developers behind CircuitPython and, kind of how it has to be this, somewhat of a subset of Python in order to fit in that memory space, which is always kind of interesting too.
Yeah.
Yeah. So you had two talks recently about type hints and protocols. And the first one was at PyCon US 2021. That one was titled Protocol, the Keystone of Type Hints. And then
Yes.
The recent one you did in September was PyCon India
Yes.
2021. And I saw the slide deck and I was like, oh, this looks really great. And looked at like kind of a bit of an iteration on what you were talking about at PyCon 2021. Is that correct?
Yeah. Well, it's sort of actually two different takes.
Okay.
But because the first one is really focused on protocols, and I called it the keystone of type hints. Because to be really honest, the people who follow me on Twitter know I was not very happy with the introduction of static typing in Python.
Mm.
I actually couldn't identify what my major issue with it was until they actually fixed the problem about 2.5, 3 years later.
Okay.
So type hints came out in 2015, and in 2018, there was the PEP. I forgot the number, but it's about protocols. What's the one?
The static duck typing, PEP 544 protocols, and structural subtyping.
Yeah, protocols, structural subtyping, and then in parentheses they call it static duck typing.
Yeah,
That was totally the missing piece, because here's the thing: if you have a team where there is a mandate that everything must be annotated, and you don't have protocols, what happens is you just turn Python into a slow version of Java, which is really sad.
Yeah, I would agree. Yeah, sure.
So so protocols was really important because then it enabled us to make annotations that make it explicit for the tools. Duck typing, which is not a bug, not a problem, not a weakness. On the contrary, is a great feature of dynamic object-oriented programming languages like Smalltalk, like Ruby, and like Python.
Right. It's been around a long time, right? The idea of duck taping.
No, it's the essence of Python. If you don't understand duck typing, you can't figure out how Python itself works. And I emphasize this a lot throughout my book.
Yeah. Okay.
Because, for instance, what is iterable? What makes an object iterable is not the fact that it subclasses a specific class, although there is an abstract-based class called iterable. What makes an object iterable is the fact that it implements a method called dunder-iter. So that's duck typing. And everything in Python is built on that idea. And if we could not express that idea in type hints, then there was really a big problem. And after the PEP came out and then Python 3.8 came out with the support of, in the typing module of typing.protocol, then at that point, I think the static type system in Python became usable to express the way that we should use Python, which embraces duck typing.
So there's a couple things there I want to kind of clarify a little bit for the audience if they're not familiar with the concept of duck typing. Mm-hmm. I like the quote that you've used a couple times, which is from Alex Martelli.
Yes.
And he says, don't check whether it is a duck, check whether it quacks like a duck or walks like a duck,
yes,
etc., depending on exactly what subset of duck-like behavior you need. I think that's a really great way of just explaining that whole idea that,
exactly,
it's not like a name per se. It's like, what does it do and how does it behave, which is cool.
Exactly. Totally. And that is not incompatible with the idea of static typing. And the greatest proof, if anybody needs that, is the Go programming language. Because the Go programming language actually popularized the concept of static duck typing. Because the idea of interfaces in Go has a keyword called interface, which is you use to declare an interface, similar to Java, but the way it's used is completely different. What are interfaces in Go are like the protocols in Python, actually the other way around, right? Because Go came out 10 years ago. So typing.protocol is very close to the idea of interfaces in Go. So the idea is you declare an interface somewhere, like, for instance, Traditionally in Python, we've used words like a file-like object.
Sure.
There's lots of words like that in the official Python documentation. A buffer-like object, there's the buffer protocol, and so on. This all predates typing.protocol. And the idea of a file-like object is like a duck-like bird. It's something that is close enough for my current purposes. And often, when you talk about a file-like object, all you care about is that it has a read method that returns a string.
Okay.
Sometimes that's all it takes. And for instance, in Go, they have an interface called reader, which is a very fundamental in the Go standard library. But now the big difference between this and the way interfaces work in Java, or the way ABCs normally are used in Python, abstract base classes, is that a class that you design doesn't need to declare, and actually has no way of declaring, that it implements reader, for instance, or the file-like interface. What you do is you implement it by providing the method with the proper signature. But there is no explicit declaration in the class that says that it implements.
Huh.
And the fact is, it has a method with the correct name and the correct signature. And then both a human reader and a tool like MyPy or PyCharm and so on, they can verify that, so this function needs something that has read method that returns a string. And this thing here, it doesn't matter what's its superclasses, but this thing here provides that method, so it matches.
Yeah, it says it does this thing. So we can kind of say...
Yeah, but not it says. I like to avoid saying that. It's not that it says.
Okay.
It actually does.
Okay.
It's because the part of saying is like you have in Java, where you say implements.
Oh, okay.
Right? When you declare a class. And in Python, it's when you inherit from an ABC, then you are forced to implement the abstract methods of the ABC. And those things are explicit. But the way that duck typing works is more implicit. And although the Zen of Python does say that explicit is better than implicit, it's actually, it's not, everything is not 100% all the time.
Right.
Like that. And the advantage of allowing this implicit thing is that it gives you more flexibility. For instance, when you're testing, it's much, much easier to mock something when the requirement is to implement a protocol that is only one method. Usually, most protocols and most interfaces in Go only require one method, sometimes two, rarely three or more. That's actually a good practice in terms of the definition of protocols. Protocols usually should declare one or at most two methods, rarely more. And that's the way useful protocols actually emerge from the code base. And they are not like interfaces designed by, architects in the.
Oh, that's interesting. So you're saying that as people are working in a code base and they start to notice these repeated patterns, that they might say, okay, let's go ahead and focus this down and say, and then that kind of relates to the type of naming that people use for protocols where, like, supports open or
exactly.
And that is actually, sort of like a verb kind of thing where it's like it does this thing.
Exactly. So, for instance, when I was studying this subject for the book, I found a few bugs in TypeShed. TypeShed is that repository that has the type hints for the Python standard library. And there were some issues there that I mentioned in my talk at PyCon India. And the issues were either false positives or false negatives. So false positive is when a type hint is too strict, so it raises the flag when actually there are no problems.
Okay.
That's a false positive. And a false negative is when the type hint is too open, is too lax, and then it doesn't catch type errors. So I found issues of both kinds, and then I contributed fixes to TypeShed by implementing protocols. And one of the protocols that I implemented, actually the one protocol that I implemented fixed two different bugs that had been reported. It supports less than. That's a protocol that is not in the standard library, but is on TypeShed. And supports less than is a protocol that is useful for anything that has to be an element of something that will be sorted in Python. For instance, the sorted function, it takes any iterable where the elements implement the less than method, the dunder LT method, because that's the only method that Python uses to compare items when sorting.
Yeah, I thought that was interesting that you found that. As you kind of, it makes me think of Brett Cannon. He's doing that whole thing of like unraveling the core Python project, and he's kind of looking at the C code, and that you would find that in the same kind of way, like just going down and seeing that is the first go-to of all the standard libraries, that it was supporting the less than.
Yes. Yeah, so then now there's a slide in the talk that mentions that after I submitted a PR with the definition for supports less than and its use in a number of methods, it then grew. People found other parts of the standard library that where the type hints benefited from that protocol. So now there are 14 different methods or functions in the standard library that use the supports less than protocol. So in those places, the annotations before were just wrong. They were either too strict, disallowing functionality that was sometimes even documented, and on the other hand, there were cases where the typing was too lax, so it wouldn't catch type errors.
Can you give an example of like something that would come through in those circumstances? I think of like strings or something.
Yeah,
potentially.
The thing was the one example where the typing was too lax was with the max. So the thing about max is that it's very flexible because you can pass a single iterable or any number of arguments. And so, of course, the first thing is that the iterable must be an iterable of things that support less than, right?
Okay.
Or the different arguments, if you pass several arguments, must all support less than. But then there's another thing. You can also pass a key. The key optional argument, keyword argument, is a function that will be used to define the criteria of comparison. And if you pass that, actually, the iterable items don't need to support less than anymore, because then Python will use the key to compare. And then, but the key function must return something that supports less than, And then there's also a default argument in the case of the max signature with the iterable. So the thing is, the max function is not difficult to use. I've taught Python to lots of people. Nobody ever complained about max. But the thing is, it's super hard to annotate.
Yeah.
And the way it was annotating, the issue that Will McGugan reported was that it was not catching when you sent in something that could be none, like an iterable of optional int, meaning that some elements could be none instead of an int. Then the type checker was allowing that instead of catching the error. And the problem was that the original signature, which had already 3 overloads, so it was quite complicated, but not strict enough to capture that kind of error. Then, with the help of Jelle Zijlstra, who is one of the most active contributors at TypeShed, I was able to write the new signature for max, which has 6 overloads.
Wow.
And this is actually an example that I use in my talk to talk about the downsides. Or the downsides, there are others. But the typing has a lot of benefits, but it has also some downsides. And one of them is complexity. So max is not particularly difficult to understand and to use correctly. And even the documentation is not very hard. It's only 1 line and then 3 paragraphs explaining the options. But the annotation of it is super complicated. 6 overloads, and one of the slides that I show in the talk is that I actually implemented max in Python because max is written in C. But I re-implemented it in Python because I wanted to step-by-step test all the different combinations of arguments, and have proper unit tests, and then check out, use MyPy to type check the arguments. And then as I evolved the code, I was evolving the signature and adding more overloads. And the thing is, if you put together in a single source file all the definitions required for the annotation of max and the source code of max that I wrote in Python, the definitions are 29 lines of code and the implementation is 26.
Yeah, that's kind of an interesting balance.
Yeah. So so what does that mean? It means that it's a clear demonstration that the type system is not as expressive as Python itself, right?
Right.
The problem is, imagine if Python always had a very, strict type system from the beginning. And even this also requires protocols to work, right? This example of max. But if we had a static typing without protocols from the beginning, Python would have evolved to be something very different and much closer to what Java is than to what Ruby and Smalltalk are, and which are, semantically the languages that look more like Python. Syntactically, Smalltalk doesn't look at all like Python, but semantically, Smalltalk and Ruby and Python are very close. But we would be in a completely different group of languages if the history was different.
Yeah, it would change the users completely too. Just like the introduction, how to get introduced to it, and
totally,
yeah.
Yes, exactly. So my talk actually, I was motivated by a tweet by Raymond Hettinger, who is a very prolific core developer. And he wrote, "I wish we had more balanced reporting on user experiences with typing. Most public talks seem to be given by people whose entire job is to make everyone in their organization use typing."
Yeah.
And so here's the thing. I understand completely the value of typing. Actually, after I started using it with protocols and so on, I use it for my toy programs as well as for my professional programs. So I use it with pleasure. But I have a certain background and a certain experience. And my background also includes a lot of experience teaching. And I've taught Python to people who were just learning to program, and I also taught Java. And Python is much easier to get started with. And one of the reasons is that we don't have this formal type system. Of course, people need to understand types. Python is not a typeless language.
No, right.
But people need to understand types. Python, even without static typing, makes it easy to understand and use types correctly because of this fail fast philosophy, which I think is one of the biggest difference between Python and JavaScript. Because JavaScript tends to try and work with what it has. So that means that when you retrieve an attribute from an object and the attribute doesn't exist, what you get is undefined. You don't get an error. You get this special value called undefined, and then later it's probably going to blow up in your face, but in a different part of the program or days later, where it's going to be much harder to debug. But Python doesn't have that philosophy, right? So if you retrieve an item using brackets in a dictionary and there's no such key, you get an a keyer right then. If you retrieve an attribute with dots and you don't, you get an attribute error. And the same thing if you add a number to a string. In JavaScript, there's all those gotchas. Depends on the order, what's going to happen.
Right.
It's nobody knows. Super hard to understand or to memorize the rules. But in Python, you just get an error. So Python allows you to understand types in a more intuitive way before you actually need to formalize them. Because the initial parts, and then there's another thing. Basic uses of typing are easy.
Sure.
Okay. You say, okay, this function returns a string. So you put this little arrow and then str. Great. Right? This argument has to be an int, x colon int. That's easy enough. But the problem is that it's not always easy.
Right. Especially if you want to have flexibility.
Exactly. That's one of the things that I emphasize in the book. For instance, you should always strive to define the arguments that you accept, not in terms of concrete, or if you want flexibility, right? Sometimes you don't want, sometimes you need to solve something really quick, right? And you do the simplest thing that will work. But if you want flexibility, then you should annotate your arguments, the parameters of your functions, with abstract classes or protocols. That gives the user of your function more flexibility when passing arguments, right?
Yeah.
But on the other hand, to return, the return type of a function usually should be very specific, not an abstract class, for instance, and usually not a protocol either, because what your function returns, first of all, you know what it returns. You should know what it returns, and you should tell the user precisely what you're returning. And if you use something that is too abstract, too high level, or too narrow, like a protocol is usually very narrow, then the user can't do much with that result. Sometimes you will force them to do a cast, to do something else. So there's all these things that you need to learn, right? About, So the thing is, static typing is something that provides more value for professional software developers. But not everybody who uses Python is or considers themselves to be or wants to be a professional software developer. We have, artists, like you were saying. We have physicists. We have bankers. We have all kinds of, of analysts in different areas of domains, insurance and social scientists, journalists, increasingly.
People creating web applications, all that stuff,
biologists, all kinds of people who, who use Python. And for lots of them, typing is something that is just not worth the investment in learning it, and it's actually, in a way, similar to unit testing. If you are a professional software developer, like we are, we know the value of unit testing and all the testing pyramids, and we totally practice that in these kinds of environments of software engineering.
Right.
But do physicists who are analyzing data from a particle accelerator need unit testing? It's probably something that in many cases will just slow them down.
Right. It may depend if they're reusing the code like across a laboratory or something like that. Yeah.
Exactly. Is it that? And that's a very good distinction that you're making, because there's actually, it's for us professional software developers, we think about, is this code for an application or is this for a library or framework?
Right.
There are different kinds of requirements, right? So, for instance, for frameworks and libraries, then that thing that I was saying before is even more applicable about flexibility. The point of flexibility that you raised is more important when you're delivering a library or a framework than if it's an internal interface of an application. But there's actually a third level, which is exploratory programming.
Yeah.
It's people who are writing code that will never be given to anybody else.
Yeah, I think of the Jupyter Notebook thing that
Yes. Exactly.
the PyCharm JetBrains people did, where they like looked at all the code and like most of this is unrunnable because people run Jupyter Notebooks in cells and they may do it out of order or whatever and so forth. So it's not. It's experimental. Yeah.
Yeah, of course. That's another problem of Jupyter Notebook. I don't know if there are good solutions to that.
Right.
I think the Jupyter Notebook should have a configuration setting that would not save if it doesn't run from top to bottom.
Sure.
Without generating an error.
Or it should be like a flag or something that says experimental.
Yeah. But I always try to remember to do that, when I'm saving a Jupyter Notebook, to reset and run all the cells from top to bottom and make sure there are no errors. But anyway, so my worry about that issue of typing and the talks that I had seen, because when Raymond tweeted that, I had already watched in preparation for my book, I think 8 or 9 separate talks about typing. And it's interesting because the one that was least evangelical about it, if I can use that word, it was the one by Guido himself, one I think he gave it at Stanford University. Yeah.
Okay.
But the others were really, so, wow, this is really a silver bullet and there's no downsides whatsoever.
Yeah.
But actually there are several. And we talked about complexity and the cost that it has in learning, and sometimes and the impact that it has on the design of APIs. Maybe if typing was mandatory in Python, I think we would not have a function like max and min in the standard library because it takes 6 lines of annotations.
Yeah.
But there's other downsides. The other downside is that Python is not the first language to have gradual typing, right? This system of optional typing. And the first 2 that are more famous were Dart and TypeScript is the most famous one. Both of them have built-in type checkers. And I think Python should have one as well, because the current situation is a little bit sad. If you use typing, you are always stuck in 1 or 2 versions behind in Python, because the type checkers are always a couple years behind.
Catching up, yeah.
And for instance, in my book, I did not annotate all the examples. Because first of all, I didn't want to annotate any of the examples before the chapter that explained type hints.
Makes sense.
But also sometimes I didn't think they added much value. Sometimes, for instance, when doing metaprogramming is something that by definition is very difficult for a static type checker, because metaprogramming is about stuff that happens at runtime, right? At runtime, you're changing the structure of a class or, dynamically adding attributes or methods and things like that. And by definition, a static type checker does not run your program. It's just looking at the source code and it can't understand what's going to happen at runtime.
Security within software supply chains has become the major focus for developer and engineering teams. Cloudsmith is a software supply chain management tool that provides public and private Python repository hosting for ultra-fast and secure delivery of your Python packages. Cloudsmith is a fully compatible PyPI-like repository. With Cloudsmith, you have the ability to develop your Python packages internally and privately share them with other teams across your organization. To get started with your own private Python repository, visit cloudsmith.com/sign up for more information. Well, I think that part of it is, like, going back to his tweet, is this idea of the survivor bias skewing the use of the use of it. And I think of, people may be not familiar with it. Or I had a kind of a nice tweet that was a follow-up recently about the World War II airplane picture that people ever use, that this idea of like,
oh yeah, that's
that is from a book that shows all these bullet holes in the plane, and people say, okay, well, where should we put armor on this to make it so that more planes don't get shot down? They go, oh, well, where all the bullet holes are. And it's like, well, actually, those are all the planes that made it home. So the places that were not holes in it were ones that need more armor. Like there were no holes in engines, and there were no holes that were shown up in the cockpit. And it's like, so like that, which is kind of a crazy concept. And in the same way that you're talking about with typing for organizations, that there is this weird, these are the companies that have done it, and or have the manpower, or they can have a specific person that is in charge of implementing it. But there's probably countless organizations that tried to do this and then said, meh, like, is it worth the investment?
Yeah.
Is that kind of where you're headed?
There's a paper. I forgot the name of the paper now, but I can provide you the link later. But there's a paper that I found when I was doing research, and I quote it in, or I think I have a link for it in my book. But the paper is about, the paper has like 4 or 5 authors, and the authors downloaded lots of, hundreds of thousands, I don't know how many pieces of Python code from GitHub, and that had type hints, and then analyzed them with type checkers. And the vast majority did not type check correctly.
Okay.
So, and they actually don't have an explanation for that, because they did not, it was outside of the scope of their work to interview the teams who wrote the code.
What happened? Yeah.
But that would be interesting, because so the status that they found out like a year and a half ago was that the vast majority of open source Python projects that had type hints probably were not using an automated type checker as part of their continuous integration pipeline, if they had one, because there was a lot of code checked in that would not pass a type check.
So they're adding it primarily as documentation.
Yes. Yeah. So I don't think there is I don't believe there is a lot of companies that tried type hints and gave up. But I can certainly imagine a lot of attrition happening because of a tendency of people, and especially sometimes management, of wanting to have clear rules.
Right.
So what's clearer than saying type hints are mandatory everywhere.
Right.
And I think my main message is that type hints should not be mandatory anywhere. They should be always optional. You want to strive in certain contexts, like in people working on a huge code base, with dozens or hundreds of developers, then type hints are going to help you, but they are actually going to hinder if you say they are mandatory all the time.
Right.
Because there are lots of downsides, and I talk about that a lot, a little bit in that talk and in the book a lot. People should come with type hints with a more relaxed attitude and a more common sense attitude. Okay, there's nothing is perfect.
Yeah.
Type hints are useful, but if you decide that everything should be annotated with type hints and pass a type checker in the strictest configuration possible, then you're going to waste a lot of time with caveats, with bugs that exist, with limitations like things that the type hints can't really express, and maybe you're gonna develop a style of Python that will not be as Pythonic.
Yeah, I was gonna say that. Yeah.
Because of those limitations. So my main takeaway is that, yes, type hints are good, but please don't make them mandatory all the time.
Yeah. I kind of wonder about two things. One, I've mentioned on the show several times why I did like a course at Real Python on type checking based on Gerhard Yellow's article that he had done. And the reason I decided I wanted to do that was I would see them in other source code, or I would see them in other places, and as a novice person to Python getting into it, I would think to myself, but that doesn't do anything. It's not altering the code at runtime at all. And so I was like, what is that? And so it was like the sort of confusion. And so I wonder sometimes, where type checking gets introduced, and you've kind of covered that a little bit already. It shouldn't be something that even in your own book that you're going to cover at the beginning of it, because it's something that you should, understand the purpose of them. And so I think that's really kind of fascinating. And I wonder, I guess what was your background getting into, it? And you mentioned already your sort of hesitation, if you will, to really embrace them.
Yes.
What was kind of the keeping you hesitant to embracing them initially?
Well, it was the fact that it disallowed duck typing.
Okay.
There was no way to express duck typing.
Okay. And so that was the flip that happened for you. Okay, cool.
Yes. So that happened in Python 3.5, 3.6, 3.7. And then only in 3.8, typing.protocol was added to the standard library.
Yeah.
And then there was tools around supporting that, and then we could use it. So I think that was really the main obstacle for me. Plus, the fact that there was obviously a lot of complexity. One of the things that I put in my book, which is really, and also I think in the talk is there are more than 22 PEPs about typing.
Yeah.
Just last week, I think there was a new one.
Yeah. You called it a parade of typing related PEPs. I love that.
Yes. Yes. And that's complexity.
Yeah.
Right. One of the things that I admire about Go, there's things I don't like about Go also. Nothing is perfect. But I do admire the commitment of the core developers, of the inventors of Go, the three guys who created it, to keep it simple. So Go had no generics for many years. Actually, more than 10 years after the first release, the next release next year is going to be the first one with generics. And it was widely criticized because of that. But also, I know that there was a great blog post by Ken Arnold, who was one of the pioneers in Java and author of the Java programming language, the official book, co-author of that book. And he wrote a blog post that I mentioned in my book that starts like this. There's no easy way of saying it, so I'm gonna say it. Generics in Java were a disaster.
Okay.
And this is a guy, you can't say he's against Java.
He's been working in it. Yeah.
Who made it.
Yeah.
And then he explains that the problem is the simple cases are simple. It's not a problem. The problem is there's always that in any type system, as you get more rigorous with the type system, there's always those areas where it becomes super complicated.
Yeah.
And this blog post is really illuminating. I think I need to tweet it again, because what he says is the difficult cases of generics in Java are so difficult that he did not understand and was unable to explain. Another author came in and said, "Oh, he did a great job," but then he mentions a footnote that they put in the chapter of the book. I actually went out and bought a used copy of that particular edition of the Java programming language book to see with my own eyes the footnote. And the footnote was like, they talked to some computer science professors, specialized in type systems. And they said, no, that's correct. That's the way it is. And so they were happy that they didn't have to understand, but it was blessed by the academics who spent their whole life thinking about type systems. So in Go, they didn't fall for that. They said, no, that opens up a lot of complexity, so we are going to just try without it. And Java did not have generics at first either, right? It came out only in Java 1.5. So, but our type system, the one in Python, is initially already had generics. It's only adding, generics was in the first PEP, and then there were 20 PEPs after that one, adding more stuff.
Yeah. I think one of the things that you cover getting into maybe the end of the talk a little bit was how type hints have very specific uses. And one of them that is kind of unsuitable is using it for checking like business rules or ways that things are going to sort of operate.
Yes.
And that's where, again, we talk about that flexibility part, right?
Yeah. I read some software development writer once wrote that the experienced software developer is something that has somebody who has developed thick skin.
Okay,
right?
Yeah.
we are thick-skinned, and so one of the things that when it's stepping back, when I was, talking about type system, about the Python type system to people who use Python in less, in other contexts that are not software engineering, people, okay, so I can say this must be a string.
Right.
Can I say it must be a string of size 3 because it's an airport code?
Mm-hmm.
No, you can't. Wow, that seems kind of trivial. Why can't I? You can't. So, okay, I can say this is an integer. Can I say it must be an integer greater than 0?
Right.
Because it's an order system. I don't want people to order 0
or
of something.
Negative and screw it up and give them a refund.
Or negative, yes. Yes. Negative, yeah. No, you can't. Can I say that the email address field must be a string, but it cannot be empty? No, you can't. So why not? Because all of these 3 examples that I gave have to do with the value. So there's a specific kind of type system. I think they are called dependent type system or something like that. I never studied a language that has this. I think even Haskell, who is famous for its very strict and powerful type system, doesn't support it. The language that I heard about that supports it, called Idris, is a experiment. I don't know. It's something that few people use. But the thing is, so for things that intuitively you would think a type system could help, it doesn't, because of theoretical limitations on the way that type systems are built. That's kind of a turnoff as well. So yeah, if you want to validate business rules, you're going to have runtime checks and also unit tests, because the type system is not going to be very useful for that.
Yeah, it's kind of funky how it really is, finding very specific things. But as you said, all of these static style type checking MyPy or other ones, they don't run your code. They sort of just look at your code.
Yes.
They analyze it,
exactly.
I guess. Yeah.
Exactly. Totally. Yeah. And so, like I said, I think type hints are a good addition to Python. I just think that we should be careful about evangelizing them. And because even in professional software engineering contexts, it's good to have people. I think it's healthy that people have the freedom to say, okay, I'm not going to annotate this particular function because it's going to be too complicated or whatever.
Right.
And it's not going to add value and so on. And I also wish that Python itself came with a bundled type checker, because the current situation is a little bit sad of having to wait 1 or 2 years for. So as I was writing the book, In the book, I did annotate many examples, and I presented pattern matching, right? And there's a significant example with pattern matching. Actually, it's Peter Norvik's Lispy that I described to people. It's a Lisp interpreter in 132 lines of Python that then I annotated and then used pattern matching because it's a perfect example of pattern matching to do language parsing.
Okay, makes sense. Yeah.
Interpretation. Yeah. But the thing is, that particular code, which is a little bit tricky, I have a version of it. Well, both versions, 3.9 and 3.10 of it. The 3.9 version doesn't have pattern matching. And I did those on parallel because I wanted to be able to type check, but MyPy, which was the type checker that I'm using, just crashed.
Oh.
Simply crashed because of the pattern matching syntax. So how long is it going to be? I've heard that the team at Dropbox that takes care of MyPy has been reduced. I think MyPy is still in the same version that it was months ago, 0.90 something. The thing is, Google also has a type checker that is supposed to be very good, but I had to pick one. I decided to pick MyPy. But it's also, it doesn't support the most recent versions of Python. Because the thing is, these huge companies that use Python, because of the size of their code bases, they are always, really catching up with the end of life of the versions.
Right.
So I have a friend who works at Google. He said, "Oh, we just got to 3.6."
Oh wow!
Or
Yay, F strings.
3.6, yeah, and then 3.7. And the type checker works for them. Because that's. So I guess probably the type checkers by Microsoft, the one that's integrated into VS Code.
Pyrite, right, is called?
Yes.
Okay.
Which is actually written in JavaScript, as a TypeScript, because it's a plugin for the VS Code, which is a JavaScript application. So it's the only Python type checker that I know about that is not, the other one is proprietary. The other one is the one by JetBrains that they use in PyCharm.
Oh, okay.
But that's proprietary, I think. And maybe it's written in Kotlin because they use Kotlin for PyCharm and their IDEs. But anyway, I think those two, because they are embedded in tools, are probably quicker to catch up with the most recent versions of Python because they would start getting lots of complaints if they didn't. But MyPy, which is the best documented of them, in my opinion, is lagging.
Yeah. This week, I want to shine a spotlight on another Real Python video course. It covers a topic we discuss in depth during this week's episode. It's titled Python Type Checking. The course is based on an article by a Real Python author and former guest, Ger-Arne Jelle. This is one of my courses, and I take you through what are type annotations and type hints, how to add static types to code, both yours and the code of others, how to run a static type checker. In this course, we use MyPy, and then how to enforce types at runtime. I think it's a worthy investment of your time to learn about type checking in Python, whether you're looking at the source code of a library you have imported or trying to document your code. It can help you understand the intent of the code. And it'll also make your code work better with advanced IDEs like PyCharm or VS Code, providing code completion and suggestions. Like all the video courses on Real Python, the course is broken into easily consumable sections, plus you get additional resources and code examples for techniques shown. All of our course lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. I wanted to spend some time just to talk about the second edition of your book. I know you've mentioned it multiple times here. I guess I should mention that it's out in a pre-release format, and then it's scheduled to be released, or I guess in print version in April. Is that right? Of 2022?
Yes. I just delivered last week the reviewed manuscript.
Okay.
And so I'm really happy about that. It's now up to them. and they haven't given me a final schedule of their part. But that's the current estimate. It's April. Yeah, so the book is. I was very happy to be able to update it for two reasons. Because the main reason was that async.io, or asynchronous programming in general, is a topic that I am very interested in, and I wrote about it in the first edition. And it was, in fact, I think the first book in print that had dozens and dozens of pages about async.io. But it was the part of Python that changed most during those years.
2015 to now, yeah, that's a lot.
Yes, exactly. So yeah, I was writing it when Python 3.4 was the latest edition, latest version. And then in Python 3.5, they added the async await keywords. So that changed the syntax, and the API of async.io itself was provisional at the time. So that meant that they could change it, and they did change it. So the examples about asynchronous programming were broken. The only examples in the whole book that did not survive those years were the async.io examples. So I wanted to fix that.
Yeah.
And of course, I also wanted to give my contribution to this super important topic of type hints. So which also came out after that first edition. So I wrote like about 200 pages about type hints.
Wow.
That is all new content that was not in the first edition.
Who do you consider to be the intended developer, like Python developer for your book? Like what level of developer?
The book is actually a book about Python for people who know Python. It evolved from a course that I used to give called Python for Pythonistas.
Okay, yeah.
Or Python for Python developers, something like that. And so the book requires that you already know the language. I don't explain the basics of the language. I assume that you know what the tutorial says and that you have some experience with the language. And so it's the first book in the market that starts with the Python data model. In chapter 1, I explain the whole thing about the dunder methods, because I think that's really something that separates a beginner Python programmer from an intermediate Python programmer.
Yeah.
When you understand how those things work, and by the way, they are completely based on the idea of duck typing. This whole thing is
right.
based on the idea of duck typing. And then you have a bigger understanding of Python itself as sort of a framework, which is interesting, because you can easily write a class that emulates that works like a sequence, but has some particular feature that you need, right? And that's really powerful. So my book is intended for people who already know Python, but I don't distinguish between people who are or not professional programmers, because actually I was very happy that one of the first praises about my book that I read in print was by a book by Springer, that publisher that publishes mostly very academic books.
Okay.
And it was a book about machine learning with 3 authors who are professors. And they recommended my book for a deeper understanding of Python.
Nice.
So anybody who really needs to get deeper into Python to know how to use it better can benefit.
Yeah, it sounds like it. I'm wondering about the Soapbox portions from the first book.
Oh, yeah.
Did you keep that as a model in the second one?
I did.
Okay.
I did. It's something that it was kind of experimental. I never saw something like that, because the idea of the Soapbox is that I'm a very opinionated person, but sometimes when I read a technical book and the author is very opinionated, if he and I agree, or if she and I agree,
right,
that's fine. But if we don't agree, then the opinions become kind of a distraction. You get, irritated. You can't reply. And
right.
You're trying to learn something, and this guy or this person is giving her judgments about this that I don't agree with. So then I thought, how can I be at the same time opinionated and respect the user who wants the facts, just the facts?
Yeah.
So I decided to have those boxes at the end of the of the chapters.
That seems like a smart idea to keep it out of the primary text. That way you can kind of like,
Yes.
if that person wants to, like, all right, well, whatever. I can.
Yeah, exactly. Yeah, so they're completely optional, and they actually don't even appear in the table of contents.
Okay. That's cool. What were other things that you were excited about sort of rewriting in the book? You mentioned the async IO and the typing.
Oh, yeah.
Were there other things that you were excited about actually sort of formatting?
Yeah, there was a chapter about interfaces and ABCs.
Okay.
In the first edition that I needed to really deeply rewrite, because now we had protocols, and that's like a third way of doing that thing. So I needed to rethink those. So I think this is an interesting chapter that became interesting. I also really liked pattern matching. I am a big fan of the Elixir programming language.
Oh, okay.
And Elixir has pattern matching built in, is really a core part of the language, like Erlang, which is closely related to Elixir. And so I really like that feature in Elixir. And when I saw it came out for Python, I followed the discussions on the Python developers mailing list.
Yeah.
And it was kind of worrying for me, because a lot of people, there was some pushback, and the whole thing is like simple in the basics, but there's some little bit of there are some special rules. And I've seen more than one reviewer of my book commented on that, because it uses Python syntax in a way that's incompatible with the syntax elsewhere.
Yeah.
For instance, the pipe operator. The pipe operator is originally bitwise OR, but you can also overload it, and it's overloaded, for instance, in the Django ORM, right, to do the union of two queries.
Yeah.
Results. It's also overloaded in the sets.
Yeah, right.
In the set class in frozen set, that it does the union as well. But it's used in the syntax of pattern matching, but it's not the same thing, because in those other examples that I gave, the use of that operator will invoke the dunder or method in the left hand operand.
Okay.
Right. That's there's this whole thing about operator overloading that Python has, which is actually, I think, one of the reasons why it's successful in science and then in machine learning. But in pattern matching, it doesn't do that. It's one place where you use the pipe operator, but it will not invoke the dunder or method of the operand on the left side. Another example is you can use something that looks like like, for instance, if I say stir open paren x close paren, I am instantiating a new string with that x argument, right? Whatever it is, it's going to be used to build a new string, if possible. Okay?
Mm-hmm.
But if you write stir x in a pattern, that is not an invocation of the constructor. That's actually a type assertion. You're saying that x must be a string. So it has this particular, it's a good feature. I ended up liking it after I got used to it, but it has some weirdness.
Yeah. The syntax is very special set of cases. And it's interesting that they were able to do that with the changes to the peg parser to allow for that kind of functionality.
Yes, they needed that. So so pattern matching was interesting, and my approach in the book is different from the other approaches of introductions to pattern matching that I saw, because of a circumstance, right? When the pattern matching was accepted and Python 3.10 was coming out, before I was going to be able to release the book, I decided that I needed to support the book, Python 3.10 in the book. So I added sections in several parts of the book mentioning new features, and that's particular feature I thought was the most important one in Python 3.10. So I gave it a lot of coverage, but I gave it coverage in different parts. So for instance, in the chapter about sequences, I talk about sequence patterns and just doing pattern matching where the subject is a sequence.
Okay.
And then in the next chapter, which is about dictionaries, I talk about dict patterns and so on. So it's the coverage of pattern matching is spread throughout the book, but then at the end, there's a very nice example that I can say that it's very nice because I didn't write it. It's by Peter Norvig.
Okay.
His LispI interpreter is a beauty, one of the most beautiful pieces of code I've seen in Python. And so I just explain it to the reader. And I say, and look at this part, the eval function, which is the main function of an interpreter, rewritten in part with the match case statement, looks really nice because it's really, I think you don't need to know Python to understand what's being defined in that part.
That's cool.
Almost it's like a pseudocode. Yeah.
Yeah. Human parsable.
Exactly. Exactly. The patterns look like the syntax, the Lisp syntax that they handle.
Oh, nice.
That's the beauty of it. Yes.
Well, cool. I'm excited to check it out.
Yes, please do. Yeah, the other thing that I would like to mention is that the last part of the book is about metaprogramming,
okay,
which is really something that's more important for people writing frameworks than applications, but I think it's useful content. And that's one part where things got much simpler in Python. So, because I was complaining about things that added complexity, and I want to acknowledge that as well. There is also improvements that happened with Python that simplified a lot. So there's this new dunder init subclass special method that was introduced, which really it's in PEP 487, simpler customization of class creation. So that special method pretty much eliminates the vast majority of uses of meta classes in Python, which is nice because meta classes are very powerful but difficult to use correctly. But the new dunder init subclass methods does most of what people usually did with meta classes. And the other new feature that I think we should talk about is that because of the new parser, Pablo Galindo Salgado, and I think other core developers, but mainly him, are contributing, because he was one of the contributors of the new parser.
Yeah.
He is contributing lots of improvements in the error messages, which are really nice.
Yeah.
Because that's something that makes Python much easier to learn.
It goes back to that thing you mentioned much earlier in the episode that we were just talking about.
Exactly. So that's what made Python so successful that now we are, number one in the TIOBE. I don't know how reliable that is, but we are a top 5 language in any important ranking out there, and we did that without static typing. And so I think we need to recognize that the power of Python has to do with the fact that it's approachable for beginners, but also powerful for professionals. And we need to keep that balance,
Yeah.
That's I think the most important message.
That whole gradualness of it.
Exactly.
Yeah. Cool. So I have these weekly questions.
Okay.
The first one is, what are you excited about in the world of Python? Again, that could be a book, package, editor, event, whatever.
I am really excited. I am excited about, I think pattern matching is a great feature, but it's something that does require some study. I think the most important feature that has come out recently really is the better error messages.
Yeah.
I'm not. Oh, okay. So I've been using Fast API, which is great. And Fast API is an example of another use for type hints, which is not for linting and documentation, which is essentially what type hints are for, but it's about having dynamic runtime effects, right?
Yeah.
Of that allow the framework to do runtime checks and with the arguments that are provided, and also generate the documentation of the API. So that's a whole new world. And I think it's very important that we keep that working as well, because there was some changes in typing recently that broke that kind of usage. But the steering committee, well, people raised an alarm.
Yeah.
And then the steering committee decided to postpone that change.
Yeah, it was good. The conversation really kind of got handled. Everybody,
Yeah.
I joke that there was like people on the sidelines, like, trying to create some kind of fight out of it, but everybody was able to kind of work together and explain the concerns, which I think is great. So
Totally. I think it was a great learning experience for everyone involved. And the big learning is that this Python is much bigger than you and the team around you.
Right.
There's people that are very different from you and I that work with Python, that use it. And so the people who created type hints were really not concerned with the runtime uses of it. But then it turns out they're useful for that too. And so we need to support that. And it's great that we are doing that.
Yeah.
So, yeah.
So what is something that, with all the things that you do, what's something that you want to learn next?
So it's interesting because I like to say that I was a web developer before the Netscape IPO in 1994.
Yeah, cool.
I actually wrote, dynamic websites in Perl with CGI and that kind of early technology that existed. And things happened in my career that actually made me become a back-end developer in the web world. But before the web, I always worked a lot with highly interactive graphical applications. Immediately before the success of the web, I worked in several commercial CD-ROM projects, interactive CD-ROMs.
Yeah.
There was that thing in the early 90s, right? And then before that, I worked with educational software.
Yeah, all those tools like Macromedia used to make. And
exactly, I was a big user of Macromedia Director and things like that.
Yeah.
And now, so what I decided after this long marathon of writing this book, what I'm going to study now is something completely different. I'm going to study Flutter.
Okay.
Because I want to go back to the front end. Of course, the front end in mobile has been around for years, and I could, but I it was sort of a turn off for me that initially you had to pick: are you going to learn this whole language or framework to do development for iOS, or this other language and tool for doing it for Android?
Yeah,
that makes no sense to me. And then there were proprietary things or things that I kind of looked at and didn't like for doing hybrid development.
Like kind of cross compilation-y kind of stuff, yeah.
Yes, exactly. And then there was React Native, but React Native requires you to use JavaScript, which I don't like. And now, Flutter seems to be very promising. There's already a huge uptake in the market, in my opinion. And the language is interesting. Dart is the language that is used. And it actually, one of the key advantages of Flutter over most cross-platform frameworks is that it actually compiles to native ARM code.
Wow, cool.
So it doesn't give Apple an opportunity to forbid, because I don't know if you know about that, but Apple has this rule that the code to run on an app has to be either native ARM code or JavaScript. And if you choose JavaScript, you cannot use your own interpreter. It has to be the one that comes with iOS.
Yeah.
Which is called JavaScript Core, is the name of the component.
Okay.
So I'm going to study Flutter and Dart because I want to try my hand at doing mobile development. And then there's also Kotlin,
that stuff's fun.
Yeah, Kotlin is also coming out with new things that are cross-platform, and Kotlin is also an interesting language that I gave a brief look at. So that's what I'm going to do. It's basically my next learnings are not driven by language, but driven by the one platform that Python doesn't serve well.
Yeah. I dabbled in Objective-C and then Swift, and I think mostly the idea of this computer in your pocket, what have you, the ability to, the web offers some of that, the ability to show off what you've created and share it with other people, but to have the program, if you will, in your pocket and show it to someone and hand it to them and have them play with it is so cool.
Wow.
Yeah.
Oh, Chris, it's really great that you said that, because I'm gonna tell you how the insight came to me. I was I was working on between the first and the second edition of Fluent Python. I was considering working on a book about Go.
Yeah.
And I actually started drafting the first chapter of a book about Go based on Alan Downey's great Think Python book, which is a book that teaches programming using Python.
Yeah.
And there's a lot of other books called Think This or That derive from his original work. And I actually talked to him and I said, I'm going to write Think Go. And I wanted it to be a book for, again, it's kind of a complement to Fluent Python, because Fluent Python is definitely for somebody who knows how to program. And more than that, for somebody who already knows how to program in Python. But I wanted to, wanted to create content for people who are learning to program. And then that's why I thought about this book following the model of Think Python from Alan Downey. But then I was actually swimming one day and thinking, when I learned to program when I was 15, I probably would not be very motivated today if I was, 15 today to read a whole introduction to programming book where most of the examples just print things on the terminal.
Yeah.
That doesn't sound like a lot of fun for a, present day 15-year-olds. And so I was thinking about that while swimming, and I thought, you know what? My next book, I don't know if I'm going to write another book or other content format. But anyway, my next content that I want to author is going to be for people learning to program, and it's going to be about learning to program for eventually to help them do mobile development.
Yeah.
And so it can't be, the best language for that is not Python and it's not Go either, because Go also doesn't have a solution. They have some experimental stuff, but no real framework for doing mobile development.
I think there's a real need for that book because I've bounced around many different tools and tutorials and other things that are out there, and obviously books, but I've bounced off so many of them just in the presentation of like how they were doing it, and it's kind of frustrating. And so I feel like there does need to be a kind of a new approach to how that's done. So I'm excited to see what you might create out of that.
Yeah, well, it's going to be real challenging. I know that, because I have no illusions about the difficulty of writing applications to run on a cell phone.
Yeah.
Even though they have multiple cores and lots of RAM and so on, it's an environment that has a lot of constraints and that has a lot of very special needs. So I don't know how long a course that starts from scratch and leads you all the way to doing something on a smartphone will take, but it's something that I want to try.
Yeah, cool.
And do.
So, do you have any last shout outs or plugs you want to give? And also any kind of social connection that you want to share?
Yeah, so my last name is Ramalho, right? Ramalho. And my Twitter account is that last name with ORG, because that's also my email. My email is luciano@ramalho.org. So Ramalho.org with 2 O's is my Twitter account, and I tweet frequently. And I also have another account called Fluent Python, where sometimes I post. I'm going to start posting more.
Ramping up
that one, because now it's ramping up for the release of the book. And I will keep everyone posted about this new initiative. I'm really excited about going back to my roots, my first 10 years as a developer of interactive applications. I'm excited to go back to that.
Yeah, cool.
Yeah.
I want to thank you so much for coming on the show, Luciano. It was really awesome to talk to you.
Thank you so much, Chris. This was a pleasure for me and an honor also, because I really admire the work you do at Real Python and the work Dan Bader does. So thank you very much for inviting me, and keep up the good work.
Oh, thanks. You're welcome. Talk to you soon.
Bye-bye.
Remember, security within your software supply chain is crucial for your organization. Visit cloudsmith.com/sign up to build your private Python repository today. I want to thank Luciano for coming on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.